today, we're going to talk about pragmatic security automation in the cloud with Python. So we have a very exciting talk in this session, and I'm going to share my experience and techniques when dealing with these types of requirements. So before I start, let me introduce myself. I am Joshua Arvin Lat. People call me Arvs. I am the Chief Technology Officer of NuWorks Interactive Labs. I'm also an AWS Machine Learning hero, and I'm also the author of the book Machine Learning with Amazon SageMaker Cookbook. So there, you'll see about 80 recipes, which would help data scientists and developers and machine learning engineers perform ML experiments and deployments. But for today, the topic will be on security and security automation. So what will we talk about in this session? So we will talk about the cybersecurity attack chain. We're going to talk about security automation with a purpose. Basically, the goal there is for us to understand the different ways we can make use of automated scripts. We'll also talk about some tips and techniques when writing security automation scripts. I'm going to share also some techniques when it comes to creating an automated data integrity layer. And we're going to talk about automated vulnerability management as well. And finally, we're going to talk about secure infrastructure as code techniques. So are you ready? Yeah, let's go. So let's talk about cybersecurity attack chain first. So if you were to ask yourself, what's this all about? What's the cybersecurity attack chain? So here, it's important for us to know that if we are planning to secure an environment, it's critical that we know how hackers would attack an existing system or environment. Sometimes you will be working and building on you'll be building systems, and you may read in some sort of blog post or comment section of a Stack Overflow link that the best practice is this, and in order to secure your implementation, this is the best practice. But if you were to take a step back and ask yourself, is this the only way for us to know that is to reverse the process, might be able to perform the attack. So in the next couple of slides, we will share a couple of examples and see how an attack changes and how the set of sequences would change as well depending on how the environment has been implemented. So here, as we can see in the screen, we have a virtual private cloud. So we have a network there with public and private subnets. So generally, most of the web application servers are in the public subnet, and in most cases, the database servers are in the private subnet. So the reason why the servers private subnet is that it's not directly accessible from everywhere else. So if you were to try to connect directly to the database servers or some of the servers there, you won't be able to connect. So in this case, we have a Kubernetes setup where some of the servers are deployed in the private subnet. However, there are some servers in the public subnet, such as the Cloud9 control instance, which we should consider as high risk, especially if it's accessible in the cloud. So if an external attacker would attack the system, of course, one of the primary ways to do it is to attack the ones in the public subnet. So being aware of which areas are exposed is the first step. And at the same time, it's important for us to know that it's not just the malicious actors from the outside which could cause the attack. It's also possible for internal employees of a company to perform the attack. So it's important for us to perform and have a setup, something like defense in depth, where even if you have secured a certain layer, it's important for different layers to be secured and for the entire implementation to be audited regularly. So here, as you can see, that setup is high risk, and if we were to add some security automation work, it can one of the first things to review would be the security of the ones in the public subnet. At the same time, if you were the attacker, what would you do? The goal is not to simply attack the system. The goal there is to steal something or to perform some task that your system is not supposed to do. So for example, if some of the servers have already been compromised, the databases would probably been dumped and stolen and downloaded from your setup. That's one. The second would be stealing the passwords. Once the passwords have been stolen, the passwords may be used against other systems. And the other thing that hackers would do is they can probably use your server to attack other websites and systems. So there are a lot of things an attacker can do. And if you think about the word hack, hack means you're able to perform something using a certain tool or system, which is not generally the common use case for that tool. So your website may be used to do something else, like attacking another system. So that said, the attack vectors do change, and the ways as an attacker would attack your systems would change depending on how your system is implemented. So if you have servers and your servers have vulnerabilities and the vulnerabilities have been exploited by the attackers, then they'll be able to use the tools and the attacks which are appropriate for that type of environment. If you have a serverless application, even if you think that your application is secure, there are still different ways to attack that kind of application. So for example, if you have a serverless environment and serverless setup, you don't manage the infrastructure. However, the code that you've written inside, let's say, the Lambda functions can be vulnerable to attacks. So if you are unable to write secure code, meaning code which can be exploitable, if you're unable to write something which can't be exploited, then of course, hackers can directly inject something into your code, in your Python code, and then perform some operations which your code shouldn't be doing. So again, in a server setup, there's no servers to manage, but still, there's code that's written from your end. So how do you secure that? The first step there is to make use of existing features of serverless services. For example, Amazon API Gateway. There are some security features there which you may check first before creating your own script. And once you have identified that you need to write your own script, then that's the time you try to add additional security layers. So you may add a WAF or a web application firewall, or you can create a custom script which prevents access to certain directories or files. So in this diagram, what we can see here is that we've made use of Lambda Edge, which is basically a Lambda function where you can write custom Python code, and it gets triggered and it gets invoked when a user accesses your site. So before the custom logic here at the bottom is executed, the Lambda edge at the edge close to the user is executed first. So you can add those security checks way before a user gets to the API gateway. So that's one of the things that you can do so that you will be able to separate the security logic from the custom code inside the Lambda functions. Yeah, so at least you're able to protect things from that layer itself. At the same time, do not forget to also add security code and custom logic near your Lambda functions as well. As I mentioned earlier, you need to have multiple layers of security there. All right. So now, let's talk about security automation with a purpose. What are the different ways we can do or we can use to practice security properly? So here, we're going to share some common techniques on how to improve the security posture of your systems and, of course, the security awareness of your entire company. So here in the first slide here, we can see that, we can use Python, to do some automation work and integrate, let's say, Nmap, um, uh, a network assessment tool with another tool or maybe another set of tools. If you are aware and if you have used Nmap before, you can technically use it by itself. So even without additional automation work, you'll be able to get it to work. And yeah, you just have to know the different options. You just have to know how to use it and also know all other features that other people do not know about. For example, people just think of Nmap as a network assessment tool. However, you can make use of existing scripts there by making use of I think it's the dash dash scripts argument. So if you're able to use that option, then you can also perform some additional security checks in your site. So people think of this tool as a purely network assessment tool, but it can do so much more. One of the reasons why you might probably do this is if, let's say, that you want some sort of custom functionality that makes use of Nmap, and then you want to make use of another tool and try to connect them, you can use Python to bridge those two things. There are different ways to do this, but yeah, if you're trying to build a system that's already making use of Python and you want to integrate Nmap with it, then yeah, you can do something like that. So yeah, so in the past, I've done something like this, and I wasn't aware of the fact that there's already different ways to automate it. So one of the things that I did in the past is I literally just used the Python code, which runs bash scripts inside the Python code in order to trigger the Nmap command. However, if you are already aware, then you can technically install a library or a package so that you just need to import Nmap. And then things are much cleaner from an implementation end. So even if you're using Python, there's still different ways to make use of Nmap in your script. And the recommended way here is to look for a library or a package where you can literally just import Nmap, and there's an API that you can use. So if you run Nmap and you want to, let's say, list the top ports, if you want to do this sort of check first before running an extensive scan, then that's one of the advantages of using this type of setup. And if you want to automatically generate a really amazing, really clean report, then the tool in this box here can be replaced with some sort of report generation script or tool or service. The other way to utilize your Python scripting skills is to do a demo. So generally, when performing and when implementing a vulnerability management program in your company, a major factor would involve people and processes. If people do not understand the importance of security, if they don't understand the security concepts and the implications of what they're doing, then it would be hard for you to enforce certain processes. So one of the recommended ways to do this is through demos, and you can technically have this sort of example where you have a password protected zip file, and you can create a custom Python script, maybe 20 lines of code, which basically just runs a brute force attack on the password protected zip file. So this would help you perform a quick demo on password strength. So people think, okay, my password will be password. So maybe in 1 second or maybe less than a second, an attacker would be able to crack the password of your zip file. So the harder it is and the more time it takes to crack the password, then the better. So with your Python scripting skills, you can write a 20-line or 30-line script, and you'll be able to perform this demo. And this is one way to not just focus on tech, but also on people as well. Because once they get to understand the implications of their actions, then you'll be able to introduce more concepts to your company and have your initiatives approved. Next would be security automation tips. So this is a very exciting part, and I'll be sharing some of the tips and techniques I'm using myself. So the first one here is to make use of Python context managers. So generally, when you're using context managers, you're probably going to use this in the context of opening a file, writing to a file, and then closing it. What I've done in the past is, in order for me to clean my code a bit and to improve the logging when I'm writing really quick and small scripts, I make use of these context managers. So as you can see in the screen, I created a custom function where if you use the with block statement, then before a certain set of statements are executed, then it would print the label and then the word start. And then when as the set of statements have completely executed, have finished execution, then we'll print the same block with end. And the advantage with this very basic approach is, in addition to automatically making your program or script easier to understand, it's much easier to debug. Because if there's something wrong with your code in some sort of function, then you'll easily know where the error happened. Because when you're writing scripts, it's not going to work 100% right away. It might break while you're writing it, and the faster you're able to debug your scripts, the better. So it will definitely be quite noisy in terms of when you're running things. But yeah, as long as you're able to debug your script really fast, then that would definitely help you save so much time compared to having a noisy set of logs. And of course, you can modify these functions and disable logging when your script is already working. So there are different variations to this one. The other things that I've done in the past is also colorizing the logs. So if you're writing automated scripts using Python and you're writing and building security tools, it's more preferable to make use of the color coding solutions where you just add some characters before and after certain string elements, and then when it's rendered in the terminal, there will be a color red or color blue, and it's much easier to read compared to a single colored set of logs. So check that out. All right, so here we are seeing a sample class, and I generally use this when trying to create a script which makes use of different configuration variables. So when writing custom scripts, which let's say perform a certain security task, one of the things that I do in Python is I create utility classes. And these utility classes would of course depend on the preference of the person writing the script. So what does this simple class do? So what it does is, if you have, let's say, a dictionary, let's say mail with nested dictionary, where you have mail and S3 file uploader as the keys, and then you have other dictionaries inside. Sometimes it's quite tricky, and sometimes it's also confusing in your code when you have to deal with configuration stored in dictionary as well. Because of course, when you're writing a script, it's better to make your script as stateless as possible. So again, in this sample script, the configuration in the dictionary would of course be stored in some sort of .env file or some sort of JSON file outside of the actual script. And once you need to load it inside your code, you need to be able to manage the chain of access variables, so that let's say that if you need to access the username of, let's say, mail, then instead of having a really long line of code, maybe you can just use node.mail.username as seen in line 15, and so on. So that allows you to separate configuration from the actual code logic. And there are different ways to do this. So again, this is just a quick example, and you may try to look for other techniques when you're trying to manage custom configuration. So once you have your script ready, you will have different environments. Let's say you have a custom scanner script. So your custom scanner script, when in staging, would make use of a different set of configuration files. Once it needs to be used in a production environment, then you can just change the configuration file and then run the same script without changing anything inside. And you will be able to scan the production environment and then finally generate a report. So those are some techniques, because when you're writing a script, the last thing you want to do is hard code credentials inside that script. All right, so those are just some of the techniques that I've used, but that should do for now, as we'll be talking about other things also in this talk. Next, we're going to talk about automated data integrity layer. So if you were to ask yourself, what's this? And why do we need to talk about data integrity of a system? So when an attacker attacks a certain system, let's say a banking application, after an attacker is able to, let's say, steal the credentials of the users, of course, the attackers may try to modify the values inside the databases. Because once an attacker, let's say, has bind shell or reverse shell or whatever access the attacker is able to have, the next step is to perform something and change something and then steal something. And sometimes you cannot steal everything inside. What you can do is, what the attacker can do is steal the passwords and then use the passwords to access certain web portals or web admin pages. But then, even if you have web admin access, sometimes being able to directly modify what's inside the database is the easier approach to make. So once the records in the database have been updated, then if you add, let's say, 1 million to a certain account, then it would be very hard to track how that account had that amount, especially if the system did not have proper logging in place when there are transactions. So being able to detect any sort of data integrity issues inside your application would help you identify if your system has been attacked. Because in most cases, people have no idea that their systems have already been attacked. So here we can see that 1 plus 1 equals 2. So one of the ways to detect security attacks and attacks which involve data integrity the data integrity of your systems is that if the numbers do not add up, then maybe it might have been modified not via your application code but from somewhere else. And sometimes people get confused when the numbers have changed a bit because it may be due to developers' mistakes, but it can also be due to an external person attacking your system. So one of the techniques that you can do is when your application is storing something in the database, instead of you trying to write auditing scripts, which may be a bit reactive, some attacks may be detected much faster when the script is inside your web application. So this may seem counterintuitive to some of us, but if you're able to write a custom data integrity checker script which does not significantly add to the transaction time. So let's say that the transaction time is 0.5 seconds and your custom data integrity checker script would make it 0.6 seconds. Then you'd be able to perform some checks before and after a transaction happens. And yeah, so let's say that the right operation was able to write 1 plus 1 equals 2. And then the total would be 2, right? But then your hacker was able to change the database contents, change the database values, and the number suddenly became 3. So what you can do in your custom data integrity checker script using, let's say, Python and SQL Alchemy, you'll be able to detect that the values do not seem to be correct because there are some formulas which are used to check the formulas and trying to compare the logs in real time. So if the set of records are loaded in real time and there seems to be something which does not seem to add properly, then you can already tag that as for review. Then you can perform the review manually. So that's one of the ways to do things because in addition to being able to prevent the issues from being deployed to production because of the developer's mistake, you'll be able to detect if your system is also attacked, especially on the database side of things. The next topic would be on automated vulnerability management. So here, we're going to make use of vulnerability assessment tools, but it should be critical for security teams to know the different ways to secure an environment and make use of assessment tools. Sometimes people think that, oh, I have this amazing security tool. I'll be able to secure the entire system by just running the tool and then patching the vulnerabilities. However, the timing is also important because when you're running a manual tool, it will require human hours. And if you're going to run, let's say, once every month, run that tool once a month, then there's that 1 month gap where your system might have been compromised already because of a vulnerability which has been deployed accidentally by your implementation team. So one of the ways to do this is to look for tools, let's say Amazon Inspector, which automatically runs when something in a system changes. So one of the cool things in this with this tool is if let's say if you push a new container, then Amazon Inspector automatically runs an assessment in the container, and then when something changes in your instance, when let's say you install something there, then the assessment tool also runs automatically, and it generates a report which you can read and review. So this means that instead of having a security team run scans manually regularly, you can depend on tools which run automatically when a set of changes happen. So this allows things to be more to be easier when it comes to your implementation team's collaboration with the security team. So that said, one of the techniques you can do there is, given that you're using Amazon Inspector, you can make use of Boto3. You can make use of Boto3 and Python to automatically set up this entire security setup so that when you have a new project, let's say you have a virtual private cloud, instead of you manually setting up Amazon Inspector and all the prerequisites required to install Amazon Inspector, you can just have a Lambda function with Boto3 and Python and some custom scripting stuff where, everything's set up automatically whenever you have a new environment. So there, the advantage there is choose the right tools and then use Python to do some additional custom scripting work to make it easy for your entire company. The last one would be on secure infrastructure as code. So when you're trying to secure your system, sometimes people think of security as having a vulnerability assessment tool and patching the systems and making sure that there are no vulnerabilities which can be exploited. However, things are trickier than what we think. For one thing, not all vulnerabilities can be patched right away. For example, you have a new version of a library which would solve any vulnerabilities existing in your system. Then, if upgrading that library version would make your system unstable, then sometimes the patches are delayed. So there are different ways to manage the vulnerabilities of your system, and one way to do it is through secure infrastructure as code. And with this approach, you'll be able to easily secure environments in a layered fashion. So let's say that you have this sort of environment and you want to convert this as code. So once you're able to convert this as code, you'll be able to create new environments and be able to run different sort of security scanners and tools in those temporary environments. So once your application has been converted to a certain template or a certain set of scripts, then creating new environments that's a clone of this original environment would be easier. And if you were to integrate this with some sort of DevSecOps pipeline, then that's possible as well. So in your pipeline, you push your code, an environment is automatically generated, a set of security scripts and scanners are executed on your temporary environment, and once the scan has finished, you can now take down and delete that environment and then push your changes to production. So in that way, you'll be able to make sure that your production environment is not affected by the scanners, because sometimes the vulnerability scanners may be harmful and sometimes noisy. and you want to do that in an isolated environment, which is very similar or maybe a clone of your production environment. So one of the techniques you can do here is to make use of Boto3, Python, and CloudFormation to perform this kind of implementation and technique. So with this one, you can make this very scalable, and then you can reuse this also in other projects. At the same time, when you're using CloudFormation, instead of having one single template for all the resources and properties of your entire environment, you can do it in a layered approach. So what you can do is you can have CloudFormation templates, let's say JSON files or YAML files, which only focus on the network level. Or maybe the IAM level where you list the permissions there. The advantage there is you'll be able to automate the rollout of configuration of your environment from staging to prod using code. So instead of you doing things manually, you'll be able to test things first in staging, maybe close the Redis port using CloudFormation templates, and when you have tested it is working and there's no impact to your application, then you'll be able to use the same template in your production environment. So this one is very practical to use, and it's easier to identify also from a security audit standpoint when this security configuration changes have been performed, because it's versioned and you'll know when these changes have been implemented. And finally, once you have this approach, as mentioned earlier, you'll be able to create multiple environments. So what you can do is, once you're able to easily roll out and create a complete environment in, let's say, 10 minutes to 15 minutes, then you can use one environment for manual testing. Because sometimes if people want to perform manual penetration testing, then you can use that environment there. At the same time, you can have another environment, which is a clone of the other environment, and use that for automated security scans and tests. And then finally, since they're literally all clones of each other, you can now create your own production environment, or maybe update your existing production environment, which is a clone of these environments. And you may not need to test that, since they're literally 100% clones of each other. And then once you no longer need the other environments, then you can delete those environments. So these are some of the techniques that you can use. And as long as you're not trying to cheat your way when trying to update the configuration files, then you'll do fine, especially when implementing infrastructure as code. So that's pretty much it. We were able to talk about a lot of topics, and being able to, one, identify what you want to secure, being able to identify how you're going to approach security, and being able to use Python properly when writing automated scripts. You'll be able to perform security automation in the cloud properly, and you'll learn as you go along, especially when dealing with security requirements. So that's pretty much it. Hope you learned something from my talk, and have a great day ahead. Bye-bye.